All right, this is the GDG Cloud RTP submission for the Powered by 2.0 TensorFlow Hackathon. Just start. They'll show you the GitHub repo. We've got a README which talks about our project goals, and it's basically there are things called USGS uh, sensors which will record water level and other things. Here's some pictures of them, one near my home. And then we have a member in our GDG, which is a company that builds something similar that helps with municipalities for doing early water level detecting. And that this is one of their sensors. And so what we were thinking is we could use them as something to teach how to use Google Cloud Platform and TensorFlow. Our users group is centered around Google Cloud Platform with a secondary goal of learning machine learning on GCP. But Greenstream, they use GCP, but they don't use machine learning. And when I talked to the owner of the company about doing a project, I was like, hey, we got to do something beneficial. And I was thinking, you would be a good person that might know how to do something beneficial. I mean, you're trying to detect floods. So basically, Jim's company has sensors, which are these green ones here on this map, and the USGS has these blue ones. And what we're going to try to do is get the data from the blue ones, USGS, and the data from the green ones, and put them together to come up with a concept of a virtual sensor. And the goal would be like there's no sensor located in this area. If knowing these other sensor readings, could we come up with a water level that might be here? One of the things that we were trying to do was to consider, like, some of these regions here are affected by the tides, not just the river flow or water level, but also maybe the wind blows it in and the tide. So we had all these ideas of all these things we were going to put in. However, gathering the data and massaging it took a huge amount of time. So we didn't get all of the data that we wanted to. Namely, we didn't get altitude, wind speed, wind direction, water temperature, air temperature, etc. But we did get these, and there was some pitch matching that had to happen. And so I'll kind of show you the code here for how we did this. I guess I could show you some of the Greenstream data because this was somewhat interesting. They used Firebase, and so we got their code to export from Firebase over to Google Cloud Storage. And here would be like a CSV file for a particular day. You can see there's different days there. And then we used Cloud Data Prep, this thing here, to merge all the data and put it into BigQuery. And over in BigQuery, we've got all the different iterations of the data that we went through. So let's look at this V3. So this would be all of the data between, I think this, let's see, USB all data matched. And let's just query this real quick. It's kind of odd. I'm not sure if I'm seeing all the fields. Let's see, query table. Put a star in there. Let's see what's in this thing. And so you would, here it's showing that this was Greenstream, Virginia Beach data, site number, a date field, tidal high, tidal low. He doesn't have any precipitation values. But anyway, so we'll show some of this in the code. So over here, we went through various mechanisms. At first, we tried to do things using all TensorFlow stuff, because I mean, I've done a lot of stuff with pandas, and then after I've worked with pandas, then get into an estimator. Now I'm just trying to use Keras, And so it's a little different, but I was trying to use that dataset API. So you'll see things like, I think this ML try 2 maybe. Let's see what this was. No, let's look at ML, the first ML try. This one. So here I was trying to read in data using the TensorFlow mechanism, where I would have missing values with hard-coded results, and I could get that in, but then later I could never get it, and I could even play games where I could use the shard capability that I didn't know how to do before, but I never could get a data set to go into building a model. So I was like, oh man, I'm running out of time. Let me just skip it and start iterating with pandas. So I went through various things here, and then let me show you the sixth one. This sixth version, we're using pandas to read the code in. Any missing values were like here you're seeing a whole bunch. Rather than adding averages in, and he was even USGS having some NaN values, I just got rid of them. Just dropped them, removed all of them. Then because it was a date time, I just created separate columns for year, month, day, and then dropped the date. So you would have something like tidal high, inches, lat long, and these are all literally values. And in this case, it's only the USGS sensor readings. We don't have any of the other readings. At one point in time, I was going to use the time of the sensor name and the type as kind of a string, and I was going to use what I learned in the Coursera GCP ML class, where you create a hash of that string and then you use that to sample it. But instead of doing this, I just did it using the sample mechanism, which is pretty much pulled from some sample code. I just normalized across all of the data. So I saw something where you could say, like, lat long, you could just divide by 100. That would work. Or you could bucketize it. In reality, I've seen how to do bucketizing using estimators. I just didn't do it here. I just kept them as normalized numbers. I played some with the learning rate coefficient. I did a couple of things. Worked with getting the tensor board to work with the multiple callbacks here. And so you can see, no, I don't have, so my tensor, I can't have any of the tensor board results here. I have to start it up. But it also using the history to print things out. You can see at least the curves here are great. They're not overlapping and they're kind of regular. If you look at some of these earlier attempts, you can see, come down here, maybe these are not. Let's try and see if this 5, if it has any of the saved prints. You can see it was not very good. Yeah, that looks really bad. So, but anyway, so in the 6th version, it worked out pretty good. And if you go down to like the samples, and what we're coming up with is here and the distribution looks good. So we're using this guy's code as an example. In version 7, which is this last one, we included the GS data, and we used the pandas mechanism to give default values for some of the readings. I was going to create a second model off of tidal low as another prediction, but I didn't. But here, he's throwing in, like, we just took the average rainfall for Virginia, and divided it by 365 and came out for the daily, since all of this is on a daily basis. And with that, our error, you can see like we've got some crosses here, which means that data doesn't really seem right, but more importantly, we got a bigger error here. You can see I've got a miles per gallon, so I'm just copying that code and using it. And that's that. The only other thing to say, let's see if there's any, it's not really, I would love to have done TFX for this stuff, but that was helpful. This was first pass. We also did a, if you go into the miscellaneous folder, it shows some of our schemas, but we even did a benchmark using some BigQuery SQL. Oh, see, my formatting is off. But this one was only done with one USGS station. We never did one with all the data, but we did one as a benchmark. And that's that.